Okay, in this demonstration, I'm going to show you how to solve a simple logarithmic equation that needs to use the product rule. I'll do another one that has the quotient rule in another video, but for right now, let's just focus on what's called the product rule. Okay, whenever you look at one of these type of problems, you should probably just stop and just take a breath and just look at it and say, what do I see? Okay, what do I see in this problem? Because usually it's what you see or what you notice that's going to help you solve this problem. Now, notice what I'm getting at here. I'm noticing two things. First of all, I see that it's an addition. And when it's an addition, that's a signal when you're adding two different logs. That's a signal that you're using what's called the product rule. Just like if it was a subtraction, that would be a signal that you're using the quotient rule. But I know that for this one, for example, it's going to be the product rule. Now let me explain that here in just a second. The other thing I'm noticing here is that there is no base underneath these logs. Okay? The base is missing. Now, why is that important? Well, you might remember, and I'll just go down here and actually do this, that to change, and let me just do this, let's make that a 3, let's make that an x, and let's make that a 2. This is a very simple logarithmic form, and you can change this logarithmic form to what's called the exponential form. Okay? The log form to the exponential form. And what is the exponential form? The exponential form says this. This number, this little subnumber, is what's called the base. This number out here is called the exponent. And this number here is what you're looking for, okay? Or excuse me, or what it's equal to. I should have said that differently. This is what the base to the exponent is equal to, okay? What the base to the exponent equals. Sorry, it's kind of mushed up in there. So what I can really do is I can convert this to the exponential form. It would be 3, the base, to the 2, which is out here, is equal to, in this case, x. And this, when you solve it, you would get 9 is equal to x. This form is called the exponential form. Okay? So you're going to have to sometimes convert from exponential form to log form, and then log form back to the exponential form. All right, so that's a little tutorial over here. So let's go back up here and see what we've got. The product rule says this. Whenever you have a number of a log that has many factors, so again, let's just go down here and do a quick little demonstration. Let's say I have the log base. Oh, by the way, I forgot to add this part up here. So if the base is missing, like it is up here, you have to assume that it's base 10. Sorry about that. Okay, so all the time, whenever it's missing, just go back up there and put a base 10. All right, so that makes it a little bit easier. Now I can convert these if I needed to. Okay, so let's go back to the product rule. The product rule says this. If I have the log of any base, it doesn't make any difference, of a number, something like, let's say 15, that can be broken up into prime factors, the product rule says that the log of each of those is the sum of the logs of the individual factors. Okay? You can add each of these individual factors, take the logarithm of each of the individual ones, and that will be equal to the log of 15. But you've got to add them. All right? So going back up here, how can we rewrite this problem as a product? Well, basically what I'm saying up here, it's going to be log, again, base 10. I just know that it's a 10 because even though it's not appearing there, we know that it's base 10. It's going to be equal to the 5 times the x. And again, that's equal to 2. Okay, so again, addition, make it a product. Now, I'm going to go back and use my exponential form and logarithmic form. I can change this to the base, which is 10, to the 2, which is the exponent, and that's going to be what it's equal to, 5x. Now look what I've got here. 10 squared is 100 is equal to 5x. Divide both sides by 5, and you get 20 is equal to x. And there's your answer. Okay? I hope that was helpful. Again, remember that you should always start off your problem by asking what you see. You should probably notice, first of all, if the bases are there, and if they're the same, they should be the same. The second thing you should notice is whether it's an addition or a subtraction or a combination of the two. If it is an addition, go ahead and do the prime factors, and remember to take the log of the individual factors. And if it's already given you in this form, work backwards, just like we did up here in this problem. Once you've got it in this form, you've got the exponential form, change it back to the, you got it into the logarithmic form, change that to the exponential form like we did from 2 to 3, and then hopefully at that point you should be able to solve your problem. Okay, I hope that was helpful.